It does fit right into our formula 1/2 AB sine C. So 1/2 times 476 times 723 times the sine of 71.3. All right, so let's plug that in. Gesundheit. 0.5 times 476 times 723 times sine 71.3. Oh, I hit the wrong symbol. Try again. 5. Sine 71.3 gives me 162,990 square feet. That's the area in square feet. However, it asks for the area in acres, and an acre is 4,560 square feet. So I have to divide that by 4560. No, 45,600. I'm sorry, not 4,560. 43,560. Thank you. So I divide that by 43,560, and I get 3.74 acres, or to the nearest tenth of an acre would be 3.7 acres. So we had to do a little conversion at the end, that's all. Anything else? Today's formula is actually really very handy. I am not going to at all go through how it is derived because it is a very, very long explanation. It is given on page 187 if you are interested in seeing it. But yeah, it's long, and it's not necessary for you to know it, but for some of you it may be interesting, so I will leave that to you to read if you're interested. It's called Heron's formula, and it's the way to find the area of a triangle when all I know are the three sides. And as you can imagine, this is kind of handy. If all I know are the three, because I can measure with a tape measure 3 sides of a triangle. If I don't have a protractor or any way to find angles, or charts, or sine, cosine, tangent, or something like that, I can find the area of a triangle using this formula without knowing any angles or any trig, basically, at all. Basically what we do is first we have to find what's called the semi-perimeter of the triangle. The semi-perimeter, as you may suspect, is half of the perimeter of the triangle. So add all 3 sides and divide by 2. Okay? S equals A plus B plus C over 2. Half the perimeter of the triangle. And then the area of the triangle can be found using the formula S, semi-perimeter, times S minus A times S minus B times S minus C, square root of the whole thing. No angles, no trig functions, no nothing. And like I said, this can be a pretty handy formula to keep in your back pocket if you ever need to calculate the area of some strange triangle for some reason. Maybe you're painting a triangular shape of some sort, and all you can do are measure the lengths of the sides. You know exactly how much area you have. Or if you have a triangular little plot of land that you need to put grass seed down for, and you know how many square feet of grass seed to purchase, you can just measure the lengths of the sides, plug them into this formula. Don't need to know any trig, don't need to have any angles. You have to take a square root, but you can always approximate that if you're halfway decent. And find the formula find the area using this formula. It's really pretty easy. So if I know all 3 sides, say I've got a triangle, the sides are 10, 14, and 20, so that means the perimeter is 44. So the semi-perimeter is 22. So the area is the square root of 22 times 22 minus 10, the first side, which would be 12, times 22 minus 14, which is 8, times 22 minus 20, which is 2. That's the area. I shouldn't use A, I should use K because we're using K for area. And all I have to do is multiply that out. Square root of 20, so 22 times 12 times 8 times 2. 22 times 12 times, I'll do the 8 times 2 is 16. 4,224. Square root of that. The area is 64.99, or almost exactly 65 units squared. Pretty darn easy. And a nice little formula to have. Like I said, this is one that's actually very potentially real world useful for finding areas. Like I say, it's an interesting equation. So some of your homework tonight, very simply, is they give you the three sides, you have to find the area. And it says to the nearest 10 square units. You can actually take it to the nearest square unit. That would be fine. And through number 20, that's all you're doing. Or through number 16, that's all you're doing, is you're finding the area of triangles. Quite simple. Now, the more interesting problems start at number 17, where it says, find the length of the altitude from vertex A to side BC for each triangle to the nearest unit. So actually find the altitude of the triangle. Well, to find an altitude in the triangle, one way you can do that is by starting with the area, because we know area is base times height divided by 2. That's our most basic formula from like 6th grade, right? And the height is the altitude. So if we know the area and I know the base, I can find the height, right? That's pretty easy. So when you run into these problems, what you're going to do is you're simply going to start by finding the area. So let's say I've got, here's my triangle, and I'm going to start without even worrying about which altitude I'm looking for, because there are three sides, there are three altitudes in the triangle. We do have to figure out the right one. But before even doing that, we're just going to start by finding the area of the triangle. So, got to find the semi-perimeter. Semi-perimeter is 23 plus 27 plus 32 over 2, so that's 82 over 2, so that's 41. 50 plus 32, 82, yes, 41. Okay. So the semi-perimeter is the square root of 41 times 41 minus 23, which is 18, times 41 minus 27, which is 14, times 41 minus 32, which is 9. Is everybody okay with where those numbers are coming from? I'm not just magically making them appear? Yeah? Okay. Plug that into our calculator. Square root of 41 times 18 times 14 times 9. And I get an area of about 305. Around it's 304.94, so I'm going to make that 305. 305 units squared. Now, area is base times height divided by 2. So 305 equals base times height divided by 2. I just need to know which base to use. Is 23 my base, is 27 my base, or is 32 my base? And here's where it gets interesting, and here's where you just have to do a little bit of thinking. It says find the altitude from vertex B to side AC. Another name for side AC is side lowercase b, right? Because across from the vertex. We name the triangle. If you're not sure about this, if you're not sure which one to choose, then draw your triangle. And we don't even know what it looks like, but that's okay. ABC, side AC is going to have to be side B, right? Because this is side A across from A, and this is side C across from C. So B is going to be my base. And that's, once I've got the numbers in there, that's pretty simple. It's 610 divided by 27 is my height. I don't know 610 divided by 27 off the top of my head. 22.6 approximately. Whatever the units are. And ladies and gentlemen, that's what falls into the more difficult problem category today. Because we have to do two different area formulas. First we have to find the area of the triangle, then we have to use the area to find the height. But like I say, if you're not sure which side you're dealing with, read the instructions, draw a quick picture, and you can quickly see which side to use as your base. One other application of this, we can use this to find the area of a quadrilateral. But again, what it comes down to is with a quadrilateral, generally we're going to need to know the measure of at least one angle within that quadrilateral if we're going to use this for quadrilaterals. Because, again, when we're trying to find the area of a quadrilateral, we're going to break it into... Whoa. Okay, try that again. Come on. Here we go. We're going to want to break it into triangles. That's how we deal with quadrilaterals, is we break them into triangles. Now, fortunately for us, finding the area of this triangle here, we go back to yesterday's formula. Or in this case, it would be, well, whatever. We get the idea. That's the general formula. Oh, this is A over here. Doesn't really matter. Our sides are 39 and 28. Times the sine of 87. So that gives me 39 times 14 times the sine of 87. Or 545.25. Okay. You're saying, well, that's great, but I still don't know side BD to use Heron's formula for the other half of the triangle, and that's true, we don't. But what we can do is we have a couple choices. I could reverse engineer Heron's formula for this area, which would be a real pain. I could use law of cosine to find the length of this side. X squared equals 28 squared plus 39 squared minus 2 times 28 times 39 times cosine of 87. And that's probably the easiest way. So I take the square root of 28 squared plus 39 squared minus 2 times 28 times 39 times cosine 87 gives me 46.8. And now I can use Heron's formula to find the area of that triangle. I could have done that first to use Heron's formula for both triangles as well. But this one was so easy to get with this formula, why bother even with Heron's? I mean, this is almost easier than Heron's for this one. It's quicker. Then I could use Heron's formula, so my semi-perimeter is 46.8 plus 31 plus 46 divided by 2. So 46.8 plus 31 plus 46 equals divided by 2. Semi-perimeter is 61.9. So the area is 61.9 times 61.9 minus 46.8 is 15.1. 61.9 minus 46 would be 15.9. And 61.9 minus 31 is 30.9. So square root 61.9 times 15.1 times 15.9 times 30.9, 677.6. And then, of course, you just add those together, and we've got the area of our quadrilateral. So basically, a little bit of geometry here that involves a little bit of trig, but finding the areas of triangles and rectangles. And like I said, through number 16, you're just finding the area of the triangle using Heron's formula. 17 through 20, you're finding the altitudes. 21 through 24 are quadrilaterals. That pretty much walks you through what the homework is tonight, too. So not too tough. And in fact, done pretty early. Okay, there we go. We can see what we got on the agenda today. Happy Veterans Day, by the way. 4, 8, 12, 16 through 24 even, 25 and 26. 25 and 26 are just, again, straight up Heron's formula. Very, very simple. Okay? Really, this shouldn't take you that long tonight. It should be a fairly easy one. Tomorrow we kind of spice things up a little bit. Throw some vectors at you tomorrow.